Hi guys, we're going to be flipping out with proportionality tonight, and you will need something to write with. You'll need a highlighter and this worksheet called Flipping Out with Proportionality. Let's go ahead and start out by writing out what is a proportion. A proportion is a comparison of two ratios, and ratios is another word for fraction. So basically, two fractions that we're comparing is a proportion. When one ratio is equivalent to another, they are considered to be proportional. P-R-O-P-O-R-T-I-O-N-A-L. When one ratio is not equivalent to another, they are considered to be non-proportional. We're going to be looking at proportionality with ratios, with tables, and graphs and equations. So let's go ahead and start off with a ratio. Label each set of ratios as a proportional or non-proportional by using cross products. That means that we multiply diagonally. Then we can tell whether it's proportional or non-proportional. So let's look at this first fraction here. We have 8 over 6 is equal to 16 over 12. We're going to find the cross products by taking 8 times 12. And we know 2 times 8 is 16. 8 times 1 is 8 plus 1 is 96. So we know 8 times 12 is 96. Then I'm going to multiply the opposite way. So 16 times 6. 6 times 6 is 36. 6 times 1 is 6 plus 3 is 96. Since 96 is equal to 96, we know that these two ratios are proportional. So we're going to go ahead and write proportional there. Let's go ahead and look at the second ratio. We have 5 over 20 is equal to 9 over 35. We're going to go ahead and find the cross products. 35 times 5, we know that's 25. 5 times 3 is 15, plus 2 is 17. So 35 times 5 is 175. We're going to go ahead and multiply the other two numbers. 20 times 9, we know, is 180. Since 180 is not equal to 175, we know that these two ratios are non-proportional. So one way we can tell whether ratios are proportional or not is to cross product the fractions. So find out what the cross products are. In part B, we're going to use scale factor. So we're going to label each set of ratios as proportional or non-proportional by using a scale factor. That means that we're going to either multiply side to side or up and down. So what I mean by that is, let's look at 2 sevenths is equal to 12 over 40. Is there a number that I can multiply to 2 to equal 12? We know 6. 2 times 6 is equal to 12. Well, let's do that same number, which is 6, and that's called our scale factor because the scale means number and factor means multiply. So the number that I'm multiplying by here is 6. Well, 7 times 6 does not equal 40. So we know that since I can't use a scale factor, since the scale factors are not the same, we know that this is non-proportional. The scale factor here is 6, and since 2 times 6 equals 12, but 7 times 6 does not equal 40, this proportion is non-proportional. Let's look at 11 over 88 is equal to 2 over 16. Well, here, instead of multiplying, finding out what number I can divide 11 by to equal 2, or even to find out what 88 divided by some number is equal to 16, I know that I can do this up and down. So I know that a number times 11 can equal 8. 88 will equal, 11 times 8 will equal 88. So if I come to the other side, 2 times 8 will equal 16. Since the scale factor is the same, we can say that this is a proportional ratio. What I'd like for you to do now is to go ahead and pause the video, and I want you to go ahead and determine whether these two sets of ratios are proportional or non-proportional. Okay, so let's go ahead and now determine whether our tables are proportional. So looking at set A, we have two tables here. We're going to take them independently. Let's look at the first one. Here we're talking about time and speed. I want to know whether this table here is proportional or non-proportional by using cross products. So I'm going to pick any two numbers, any two sets of ratios in the table. If I go ahead and write a line like this, do you see how I now have two fractions that equal to each other? So what I'd like to do is to go ahead and multiply the two diagonal numbers, and I know 15 times 2 equals 30, and 1 times 20 equals 20. Do those two numbers equal each other? They do not. Therefore, I know that this table is non-proportional. Now, I could have used any two numbers in the table. I could have used 1 over 15 and 4 over 65. It didn't matter which set of numbers. They all have to be equal. So let's look at the second table. Let's go ahead and look at 2 over 10 and 3 over 15. If I multiply 2 and 10, I get 30. And if I multiply 2 and 15, I also get 30. Let's come over here and let's choose two other sets of numbers. Let's go ahead and do 9 times 35, which is 315, and 45 times 7, which is also 315. Now notice, 30 and 315 are not equal, but when I did one set of ratios, these two numbers equal each other, and these two numbers equal each other. Therefore, this is a symbol that means therefore, this table is proportional. So let's go back. On this table here, on set A, because I used one set of ratios, 1 over 15 and 2 over 20, and I cross-multiplied 20 times 1 equals 20, and 2 times 15 equals 30, because this ratio did not equal each other, I know that the whole table is non-proportional. In this table here, since independently these two ratios were equal to 30 is equal to 30, and 315 is equal to 315, this table is set to be proportional. Let's look at B. We can determine a table. Instead of doing cross products, we can also use a scale factor. So just like we did in part A, determining whether ratios are proportional, we can look across a table. So I can see automatically that I can multiply 1 times 8 and it'll equal 8. So I want to see if that multiplying by 8 will work all the way down. Well, 2 times 8 equals 16. I'm looking good so far. 3 times 8 is equal to 24. And 4 times 8 is equal to 32. Because the scale factor works all the way throughout, is the same all the way throughout, we know that the table is proportional. Let's go ahead and look at the second one. What number can I multiply to 2 to equal 6? Well, we all know that we can use 3. So I got to make sure that 3 works all the way through. So 4 times 3 equals 12. 6 times 3 does not equal 20. It equals 18. And then 8 times 3 is equal to 24. But because it did not work for every single number in the table, we're going to write that the scale factor is not the same. Therefore, it is non-proportional. This whole table is non-proportional. All right, let's go ahead and look at the back. Here we have label each table as proportional or non-proportional by using your method of choice. So what I'd like for you to do now is to go ahead and pause the video, and you go ahead and do these two tables and determine which one's proportional and which one's non-proportional. All right, looking at graphs. We're going to go ahead and fill in these set of notes here. We're going to write the graph of a proportional relationship is always a straight line that crosses through the origin at 0, 0. So a graph must be a straight line and it must go through the origin. So those two conditions must be met in order to determine if it's proportional or non-proportional. So let's look at A. What I'd like for you to do here is we're going to label each graph as proportional or non-proportional, and then we're going to tell how you know. Well, the way we can figure it out is by writing the word straight and origin. So I'm going to look at the graph now, and I'm going to determine whether this line is straight. And I'm going to put a check because it is. Does it go through the origin? Well, we know 0, 0 is the origin. And yes, in fact, the line does go through the origin. So therefore, this graph is proportional. I'm now going to abbreviate proportionality with a P. If it's non-proportional, we're going to write NP. So let's look at B. I'm going to go ahead and write whether it's straight, and then write the word origin. The line is straight, so I'm going to put a check, and then I'm going to go ahead and determine where the origin is by putting a dot. And does that line cross through the origin? It does not, so therefore I'm going to label it non-proportional. C is what we call a parabola, and you guys will see that when you get to algebra next year. So we're going to go ahead and write down whether it's straight and if it crosses through the origin. Well, obviously we can tell that the line is not straight, but it does go through the origin. But remember what we said, it has to meet both conditions. So because it is not straight, we have to label this non-proportional. What I'd like for you to do now is to go ahead and do D, E, and F. So go ahead and pause the video and determine whether each of these graphs is proportional or non-proportional. Okay. The last way we can determine proportionality is by using an equation. So proportional equations follow the format. We're going to write y is equal to mx. So that means it's going to be y is equal to some number multiplied to x, and that is the only way it will be a proportional relation or a proportional equation. So for example, we can write down y is equal to 1/2 times x. So we know y is equal to m here is 1/2 and x is the variable x. Or it can be a negative number. We can do -4 times x. So it's okay for the number to be negative. The sign doesn't matter here. We just want it to be y is equal to some number times the variable x. For non-proportional equations, they follow the format y is equal to mx plus b. Now, it doesn't always have to be plus. We could write plus or minus here. So I'm going to do plus or minus b. So for example, we can have y is equal to, let's do -3x plus 5. So we see here that m is the -3 being multiplied to x, and then it's plus 5. So here, plus 5 is the plus b here. So we can also have a fraction, so we can do y is equal to, let's do 2x plus 1.5. Or we can make it minus. Let's do minus. Let's do 2x minus 1.5. So here, y is equal to 2. 2 is the same as m here, and 2 is being multiplied to the variable x, minus 1.5. And the minus 1.5 is represented by the letter b. So let's go ahead and look at some examples down here at the bottom. The first one is y is equal to 3x. Which format does it follow? Does it follow y is equal to mx or y is equal to mx plus b? Because nothing is being added or subtracted here, it's 0, we're going to say that this is proportional, and they want us to circle the answer. So circle the equations that are proportional. So we can circle it and write the letter P to show that it is proportional. Let's look at C. Y is equal to 5x minus 1. Well, does it follow the y is equal to mx or y is equal to mx plus b? We know that this follows the y is equal to mx minus b. So therefore, this is non-proportional because it has a number that is being added or subtracted to a number being multiplied to x. What I'd like for you to do is to go ahead and complete B, D, and E and determine whether they are proportional or non-proportional.